So as with previous examples, we'll start off with some concrete numbers to fiddle with in order to show that this works. Let's take x to the 5th and divide it by x squared. So x to the 5th, that's x times x, cross there.
Are you actually going to write something into the y? Like, is that just there?
Yes, this is part of the y. And the y is there because, hey guys, Izzy, turn around. This is showing why the rule works.
Okay.
So x to the 5th over x squared. Now, if I think about what I learned in previous classes about division, this x is going to cancel with this one. This is going to cancel with this one. That leaves me what?
X cubed.
X to the 3rd, or x cubed. So is there a way I can get from 5 and 2 to 3? Subtract them. So really, when I do division, it's really a subtraction of the two exponents. Yeah, I'm sure you guys have seen this before. Pardon? No, that's cross multiplying. That's a different thing. So the rule is this. Hey guys, rule. Let's use different letters. P to the A divided by P to the B is P to the A minus B. Now, one trick to this, if you remember multiplication, we added, division is the opposite, so we subtract. If you remember comma, not colon, multiplication is addition. This is the opposite, so we do the opposite, we subtract. Now, one other thing to mention in here. So in this case, this is the rule. And in this concrete example, x to the 5 over x squared, 5 minus 2 is 3, so we get x to the 3rd. You subtract it. If you're dividing, subtract the exponents. If you're multiplying, add them. And if you're raising to a power, you multiply.
How do you just do variables?
Yeah.
Would it just be P, maybe?
Well, let's say I had 3 to the 8th divided by, guys, can we cut off the side noise?
Yeah.
3 to the 7th. Now let's make it 6th.
I know, like, you can't combine A minus B.
Sure you can.
How can you minus A from B?
Well, here. A is 8 minus B is 6. So I get 3 squared.
Oh, I know.
Yeah. This is just the rule. Now, another why I want to mention while we're talking about such things. Let's do this. I'll use real numbers. 4 to the 3rd divided by 4 to the 3rd. Let's use this rule of exponents. If I have the same base and I'm dividing, what do I do to the exponents?
You
Minus them. So this would be 4 to the 3 minus 3, right?
0.
Which is 4 to the 0.
But isn't it always 1?
Well, let's see, 4 to the 3rd, that's 64, divided by 64, which we know is 1.
Yeah, but
So, 4 to the 0 must be 1.
What exactly did you come out with, like, the fun way to do?
Well, remember the rule that we just talked about is, if you divide two things with the same base, you subtract their exponents, right? Well, remember we talked about this 0 power rule, that anything to the 0 power is 1? Well, if I take anything, x to the 8th, divided by x to the 8th, that would be x to the 0, right? But anything divided by itself is 1.
Just skip a step.
So the reason we have this rule from a few sections ago is because of this rule here. The reason that anything to the 0 power is 1 has to do with this idea that if I were to divide it by itself, subtract the exponents, I get 0, and therefore I get 1. The rule works. Anything to the 0 power is 1.
If you put 1 as the answers are wrong, you have to put 4 as 0.
No, you put 1. If you ever have anything to the 0 power, you put 1. Boom, done. Don't think about it too hard. Now, these examples, let me go ahead and pause here. We'll start a new tape.